Guys, is it visible?
Yes, sir.
Yes.
Yes, sir.
Okay. So you keep a pen and paper with you, so that you can solve the problem. So the next one is your candidate elimination algorithm. So yesterday's class we have discussed about the finders algorithm. So finders algorithm, it may not be a consistent, or it is inconsistent because we are considering only the positive hypothesis. So now this candidate elimination algorithm will considers both your positive examples and the negative examples, right? So but when you implement the same algorithms in the lab part, you will come to know how far it is giving the result compared to the finders algorithm. So that is the reason, right? So why we have reached so many algorithms and technologies so far, because we have drawbacks in one and another. So in order to solve such drawbacks in the existing method, we are proposing another methods, right? So now the candidate elimination algorithm, it solves the problem of finders drawbacks. Uh, Now here we will have a two hypothesis. One is general hypothesis, another one is the specific hypothesis. General hypothesis represented with the Z, and the specific hypothesis represented with S. So hypothesis in H is nothing but the whole subset, whole the set. So now this general hypothesis represented with this question mark symbol. Each question mark represents the number of attributes in the subset. Same here, S is nothing but a specific hypothesis. Phi is nothing but the same the number of attributes in the set. So that is what this candidate elimination algorithm with run with the help of these two hypotheses. Now directly I'll take you to the problem. So and before that we should know the algorithm. So what algorithm says, first you need to consider, you need to initialize the S0 and Z0. So nothing but your initial hypothesis, specific hypothesis and general hypothesis. Now the step one says initialize Z0 and S0. Then for each positive example, we need tend to generalize the specific hypothesis, meaning you need to update the specific hypothesis. For each negative example, we need to make a general hypothesis more specific. This simply you can say you here you need to update the general hypothesis for every negative example. For every positive example, you need to update the your specific hypothesis. That is what algorithm says. So now we'll take on problem. So we can take this problem, same problem, but the order I have changed. Sunny, warm, high, strong, cool, and change is your first positive set, positive example. Then the second one is your negative example, negative instance. Third instance is positive instance. Fourth instance, your again positive instance. Just here I solved the problem, but let me put it in this final answer sheet so that you will get to know. Here, so now this is your, you can write it in a piece of paper. You can just note down this: sunny, warm, high, strong, cool, change. I think noted, right? Now I will take the first instance, I1. Sunny, warm, high, strong, cool, and change. The second instance is rainy, cold. So here the first two instance, these two are contradictory. So you just keep it in mind. Rainy versus sunny, cold versus warm. Then the third attribute, fourth attribute is same. Then fifth is again cool versus warm. Here change versus change. So the fifth one is changed. 1 and 2 and fifth one is changed. So now we will go to the problem. So now I am taking the first instance, sunny, warm, high, strong, cool, and change. What algorithm says? First, you need to define both specific attribute and specific hypothesis and general hypothesis to the base static one. So specific is nothing but 5, general is nothing but a question mark, right? So now the first one, you take the first instance, I1. I1 is nothing but the first instance, sunny, warm, high, strong, cool, change. So initially I don't have anything to compare. So initially I will take my high instance as my hypothesis. So since it is a positive example, so I am considering only yes specific. So as per step 1, I need to change only the specific hypothesis. So S1 is nothing but my instance 1. So yes, sunny, warm, high, strong, cool, and change. So here I am since it is a positive example, so you no need to do anything with the general hypothesis. So you can leave as such. Then I2, the second instance, I am taking the second instance. You can see here, second instance is rainy, cold, high, strong, warm, and change. So now what I need to do, I need to compare the second instance with the S1. I need to compare the second instance with the S1. Now you can compare the second instance is rainy versus sunny. Sorry, since it is a negative example, I need to only update. I need to make more general hypothesis as more specific. So I need to take only G2. So S2 is nothing but S1, same like S1, because here I no need touch anything. So S1 is nothing but S2. So SWHSCC. So now since it is a negative example, what I need to do, I need to compare the attribute with the hypothesis. Suppose if there is any contradictory, then I need to make the individual pair of hypothesis in general. So I repeat, wherever there is a contradictory, then I need to make the individual pair of hypothesis as more specific one. So now I am taking this yes sunny versus rainy. Now yes, I need to compare S2 with this one. So rainy is equal to sunny. So these both are mismatch, contradictory. So I need to make my individual pair of specific hypothesis as a general one. So this sunny become my general. So now I'm making individual pair. So in the place of sunny, I'm keeping sunny. So S2 versus rainy. So it's a mismatch. So I need to make my general specific hypothesis as a general. So sunny will become first hypothesis. Sunny, comma, remaining is a question mark. I don't know about other attributes. Now the second one, I am taking W with the cold. So warm versus cold. So warm versus cold is also different. So I need to keep the second hypothesis as such, the remaining hypothesis as more general. So now warm will be my second hypothesis. First one is question mark, general one. I'm making general. Second one is warm versus cold. So these two are contradictory. So I'm making my second specific hypothesis as a general one. So remaining is question mark. Then the third one is your high versus high. So both is equal. So you can leave that. You no need to make any individual pairs. Again, strong versus strong. So that is also equal. So you can give a pass. Fifth one, cold versus here cold versus warm. Cold versus warm is nothing but contradictory. So I need to make my cold as my hypothesis. 4 question mark C, and the last one is question mark. Again, the final one is change versus change. So that is again you can give a pass. So the only general specific hypothesis is sunny, warm, and finally cold. Sorry, cool. So these are my general hypothesis. This is what your negative. For negative hypothesis, you need to do like this. Wherever negative hypothesis coming, you need to make the individual pair of hypothesis. That you should keep it in mind. Then the third one, what is the third one? Sunny, warm, high, strong, and warm and same. What is a sunny here? The third one is sunny. So I am comparing sunny versus sunny. So same. Again, the third one is again warm versus warm, same. Again, high versus high, same. Then strong versus strong, same. Then fifth one is warm versus cold. My third instance is, you can see here, third instance is warm, but my S2 is here cold. Again, the fifth one, same versus, what is here? Same versus change. So these two are contradictory here. So I repeat, my instance 3 is strong, sunny, warm, high, strong, and warm and same. But here, whereas here, cold and change. So these two are contradictory. So I need to make this as a more general one. So this two will be changed. I hope you got it. So since it is a positive test case, you no need to worry about the general one. So you copy paste the same. Yes, swarm and C. But see here, C is I have not written. I will tell you why. So now the fourth one is again, it is positive hypothesis. What is the fourth hypothesis? Sunny, warm, normal, strong, warm, and same. So sunny, warm, normal, strong. So now this instance 4 is compared with S3. So sunny versus sunny. So same. So you can keep sunny. Again, warm versus warm, same. Then the third instance is normal versus high. So these two are contradictory. So I need to change my specific hypothesis into general one. So question mark. Then the fourth one is your strong versus strong. So that is equal. Then the fifth one is warm versus. So this is already question mark. You can't do anything. So that will also be contradictory. So we need to make question mark. So this is your yes 4. Okay. So now the more we are making more specific hypothesis. So then sunny versus warm. Then the last one is strong. So whenever there is a climate like this, then the person will use to come and enjoy the sports. That is the most specific hypothesis here in case of finders. Now what general says, so general is nothing but since it is a positive test case, here you no need to touch anything. You keep the same sunny and warm. So specific also sunny and warm. Here general also sunny and warm. What about this one? The last one, the third one. Now you can compare here this G2 versus S3. What G2 says, this the fourth one will be a cold. Fourth one will be the what is cool here. This is the more specific one, but this is general one. But S3 says both become the your gender specific general one. So this is your specific, this is your general. So here there is a contradictory happens. G2 versus S3. So when I calculate G3, I am comparing the previous state. G2 versus S3. So here there is a contradiction. Even you compare with S3 versus S2, since these two are general one, specific one, these two are general. So here also there is a contradictory happens. So what I need to do while considering the G3, I need to eliminate this hypothesis. So this hypothesis will be eliminated. So that is what this algorithm is, candidate elimination algorithm. Wherever there is, when you compare the hypothesis, wherever there is a contradictory happens, so then you need to eliminate that hypothesis. See here, there is a 4 question mark and C and question mark. But the fourth one is because we are comparing the S3 versus S2. So then their general hypothesis also we should compare. But here general specific hypothesis says here there is a CC is becomes general one question mark. But here the third hypothesis becomes specific here. But whereas here is general, here is specific. So how this is possible? So this may not be possible. So this one will be eliminated when you generate the G3. So that is what this one is eliminated. So once it is a question mark, then it should be a question mark. You cannot, one cannot be a specific, again others cannot be. So, but if you keep a question mark here, you can keep anything. Either you can keep this question mark represents either a cool or warm. This question mark represents either a change or same. But here it says only cool, but here it is a general. So this may not be possible. So this will be eliminated here. So my general specific hypothesis is yes, 4 question mark, warm, again 4 question mark. So this is my answer here for this question. Conclusion is for positive, you change the specific hypothesis. Wherever hypothesis contradiction happens, we should eliminate it. That is what this is called elimination algorithm. Just I written in my own words. So steps 1 and 2 I written for basic understanding. So just later on, this is your final output. So this is, you need to generate it. So when you implement the same algorithm with the Python, you will get the step by answers. So I1, I2, I3, I4, I4. So this is what it will happen, right? Now I'll give you another, I will give you an example. So now this, you can try this. I'll remove this. Show taskbar. Now you can see. I hope you understand, right? Or else you just derive it. I will tell you where to eliminate. So now you can take this as example. This table, Sunny here, first 2 are positive, third one is negative, then fourth one is positive. Can you try this now and tell me the answer? Final yes, 4 and G4. You just tell me. People can tell me what is a S1 and G1. Let me check. Those who understood, you can try. Even I'll show you the previous answer. Accordingly, you can try.
Sir, show the question once.
The question.
Yes, sir. Oh, so okay. Next one. Any answers? Can you say me yes? Yes, one G1. Yes or no? Yes, one and G1.
S1 sunny, warm, normal, strong, warm, same.
Yes. G1 is all question mark. Yes, very good. Yeah. S2, G2.
S2 sunny warm question mark.
Yes. By seeing the, because first two are positive data set, by seeing this you can guess. So sunny equal, warm equal. So high versus normal. So there is a contradictory. So then this S2 become a question mark. So sunny, warm, question mark, strong,
Strong.
comma, warm, comma, same. Am I right?
Yes, sir.
Yes, very good. Now this is your turn. So if you come up with the answer, then you will be in the right track. So since it is a negative example, the third instance, so you don't want to touch the S specific one. So S3 is nothing but S2. So you keep S3 as S2. Sunny versus sunny, comma, warm, comma, question mark, comma, strong, comma, warm, comma, same. That is your S3. Now can anyone tell me G3? What is that? You take the instance I3 and compare with S3 and tell me. That's it.
So the one with the contradiction, they will be individual.
Yeah, they will be individual pairs. What is the answer?
High and like sunny, warm, high, strong, warm, same. Sunny, warm, normal, strong, warm, same.
No. Sunny, comma. What is the first pair? G3 first pair.
Sunny,
Just
comma,
Sunny,
everything question
warm,
mark.
sunny is everything. Sunny,
sunny, comma, question mark. Why should I again warm is coming? Because you are making individual pair. You are comparing one versus one attribute. So one and one attribute, right? So you are comparing rainy with sunny. The third one is rainy. The S3 is nothing but sunny. So you should update only this remaining attribute should be a question mark. That is a pair, first pair. So first pair is sunny, comma, question mark, question mark, question mark, question mark. The second one is you are taking the cold. You are comparing cold with S3 or the second attribute is warm. So cold versus warm again is a contradiction. So this become then for when you compare the second attribute, first attribute become question mark. Then this become warm, question mark, question mark, question mark. You need to take the previous attribute as your own specific attribute. So question mark, comma, this will become warm. Whenever contradiction happens, the specific becomes general. So warm, comma, question mark. Then third one, high versus high. So a pass. Strong versus strong, pass. Warm versus warm, pass. The last one is change versus same. So what I need to do? So again, this are all question mark, then this become same, right? So this is your answer. This is the three pair of thing. The what is the last answer?
Sir, SW question mark S and question mark, sir, for S4.
S4 is sunny, comma, warm, comma,
Question mark,
question mark,
mark,
comma,
strong,
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 question
comma,
mark.
question mark.
question mark and question mark.
Yes.
What is a G4? G4?
S comma question mark comma question mark comma question mark comma question mark. S and W will be there, sir. Only S and
Yes,
W.
yes. The last one will be the third individual pair of G3. Question mark, last is same. That will be eliminated because S4 and G3, there is a contradiction. You check S4 and G3 contradiction. Last two will be a question mark in S4. But whereas in G3, it says the last individual pair is all question mark and same. So there is a contradiction, general and specific. So that will be eliminated here. So the final pair is S4 is sunny, comma, warm, comma, question mark, comma, strong, comma, double question mark. Then G4 is nothing but sunny and warm, only two individual pairs. Now you can check your answer. So this is your S4 and where is your G4? Yeah, this is your S4 and your G4. Sunny, warm, strong. Here there is a question mark, double question mark. You can see. So I'll show you from the beginning. Those who are not understood, you can check once. Initially, this is 5. Now first S1 is nothing but sunny, warm. I am taking the same as attributes as same here, S1. Then now S2 is nothing but same. This is positive data set. So I am changing only S1. Sorry, I am changing only specific S1 and S2. I am not touching G0, G1, G2 because first two are positive example. So I am not touching the G series. I am updating only S. So for S1, the same answer. S2 also positive. So I am comparing sunny versus sunny, sunny. Warm versus warm, warm. Normal versus strong. So these two are contradictory. So I am keeping question mark here. Then strong versus strong, same. Warm versus warm, same versus same. So same. So same will be the answer. So S2 is same. For S1, G0 is nothing but all question mark. S2, G1 is also all question mark. Now we will move on to the third instance. Now my S2 and S3. So what is a S3? What is a third instance? Rainy, cold, high, strong, warm, and change. Now I need to create a S3 for instance 3. What I need to do? I need to compare rainy with the S2. S2 is nothing but the previous one. Rainy versus sunny. So there is a contradiction. So what I need to do? I need to take the specific hypothesis as a general one. So I am making sunny as the answer. Cold versus sunny. So again warm is the answer. Sorry, cold versus warm. So warm will be the answer. High versus what is the S2? High versus question mark. So question mark will be answer. Strong versus strong. So you can keep strong. Warm versus warm. You can keep warm. Change versus same. So there is a contradiction. So you need to keep same as the answer here. So now this become your S3. What is a G3 here? There will be a 3G3. So now I need to compare. Sorry, I did wrong. So since it is a negative test case, so I no need to update the S3. So you can take S2 as the S3. That is why I kept S2, S3. I thought it's a positive. So now I need to update only G3 series, right? So G3, what I will do? I will compare rainy versus sunny. So whenever there is a negative, you take the instance and compare with the specific one. So rainy versus sunny. So sunny is the answer. So my sunny is my first pair. Sunny, comma, all question mark. Again, I am taking cold versus warm. Cold versus warm, there is a contradiction. So this is the second attribute. So the first become question mark, then warm will be the specific one. So remaining is a question mark. High versus question mark. So this will become question mark, that you can leave it. Whenever that is a specific already, that you can leave it. Then strong versus strong, you can leave it. Again, warm versus warm, you can leave it. Change versus same. Wherever there is an attribute comparison only, we should consider. Remaining should be a pass. Then same versus change. So here there is a contradiction. So then same will be kept as such. So remaining are question marks. So this is my G3. So this is my G3. Now here, then what is the fourth one? Fourth instance. Now this is S3 and G3. Now we'll take the fourth one. Fourth one is nothing but my positive test case. So now I need to generate S4 because since it is a positive, I need to generate S4 and G4. So S4 is nothing but since it is a positive, I will take sunny versus S3. I need to compare fourth instance with the third one. So sunny versus sunny is the sunny. Warm versus warm is a warm. High versus question mark is a question mark. Strong versus strong, strong. cool versus warm, that is a different. So I need to put it as a question mark. Change versus same. So that is also change different. So I need to put question mark. So now this will become double question mark. In S3, last two columns are warm and same. But whereas in S4, these two columns are contradictory. So this will become changed as the more specific general one. So question mark, question mark. From here, I need to generate G4. I need to just copy paste, copy the reference. I need to do the memory reference. It's a copy reference. So G4, where will I take? I need to take from the G3. So now I need to check here. G3 is nothing but this statement, sunny, warm, and same. But what does the third attribute says? The last two columns is one is a general one, the last one is a specific one. But whereas here in S4 says the last two columns are more general. But whereas here it is a more specific. Last one column is specific. So these two are contradictory now. So I need to eliminate this statement. The last instance, I need to partially eliminate this one. Remove from yes any hypothesis that is more general than the any other hypothesis in yes. So this is what this statement, you can read this statement, remove from yes any hypothesis that is more general than the another hypothesis in yes. So here this is the more general same, but here is a question mark. This is a question mark, question mark. This is matching, but the last column is not matching. So this can be eliminated. So your final answer is going to be sunny and warm alone. Here sunny, warm, and strong. So this is the answer. So in between parameters are nothing but your version spaces, S3 and G4. So now I am by considering this sunny and strong, these three parameters, I can generate these three subsets. By keeping sunny and strong, I can write this. For keeping sunny and warm, these two, combining these two, I can get this. By taking warm and sunny and warm, I can generate with the help of warm, I can generate this. This is the three possible version spaces by combining these orders. So sunny, strong, sunny, warm, and warm, strong. So these are the only three items are here. So with that, you can generate these in between hypothesis. So this is called your version space. So that is what your version space is all about. So this is the answer S4 and G4 for this hypothesis. The same thing you can try it in Python, so you will get the answer. So this problem we solved as a first example. So that is, we can leave it. The same answer, I kept it here. So that is what. So disadvantage of this candidate elimination algorithm is this is very sensitive to noise, meaning if there are any training error in the samples, then it will perform very poor performance. It will give you very poor results. So there should not be any error in that hypothesis, whatever we are taking for instance 1 and 2. That we should take care. Also, if there are any missing values on errors in your training sample, then it will converge to empty version space. So when you run the program here, you may not get anything. Suppose if there is any error in the set here, you may not get any version spacing. So that missing values also you should not be there. That is what the disadvantages of this algorithm. If there is any error or missing value, then you will get empty version space. You may not predict the results. So that is what this algorithm of this find S algorithm and this candidate elimination. So you can take any number of examples and you can try. Suppose if you try to implement it in Python, you no need to solve in piece of paper. You can try it. You can run the code and you can get the result. So this is how your first half of the module 1. The second half of the module 1 is nothing but we have still decision tree. Where is it? Syllabi. Now learning problem, perspective and issues, concept learning, version spacing and candidate elimination. Still we have inductive bias, that is just a definition. Okay. decision tree representation algorithm. Okay. Decision tree, ensemble algorithm, and random forest. 3 concept that we'll see 3 concept in next week. I mean tomorrow we have one class. Okay, we'll try something, any other inductive bias and any other ensemble algorithm. So 3 classes we will finish 3 topics. For each class we will finish 1 topic so that we can plan with that RRs. So next class we'll see decision tree. Okay. Okay. Okay, is there any lab is assigned so far? It's not assigned.
Not assigned, sir.
Not assigned, sir.
But we got a mail saying that lab will be assigned soon, but I don't know. Okay.
So this time, like, we don't have a choice to choose our lab teacher. Dean Academics is doing it.
Yeah. You can't online client, on lab client. It's very difficult to give such options to. So okay. So can anyone try these 2 programs tomorrow in class, Jupyter Notebook? Can you teach to other students how to install Jupyter Notebook? Because since it's new, few of them are unaware. They messaged me, they don't know how to install and run. If anyone is interested, can you give a demo? Rahav, can you give a demo tomorrow?
So can we use Google Collaboratory, sir?
Yes, sir. Google Colab is I use.
One guy can give Google Colab, other guy can give a Jupyter Notebook, because it with any one tool. That is people convenient. Let them use. Then 2 people can give demo. Raghav, you give in Google Colab.
Yes, sir.
I will share the second candidate algorithm also in chat box. You just download the data set and run the code and show them people, line by line.
Okay,
then just how to download and how to install. Make it as a PPT or make it as a PPT better, because when you do it in live, it will take time installation. You just try to install in your machine, take a screenshot of each installation step and put it in PPT. Finally, once you shown the demo, then you can open the Colab and you can run the code straight away and you can show the output. Okay.
So in Google Colab, I think we can do it in online only, sir. No need to download anything.
Yes, sir. No need to install anything, sir. It's
but
online.
Jupyter you need to install Anaconda, right?
Yes, sir. For Jupyter, we need to install Anaconda, but for Google Colab, the Python was inbuilt. We need not.
Then just to give a demo, no problem. But my point is, you should not make people to wait for installing and other things. I don't want to do that. So remaining part you can take it. Kaushik, can you do it with Jupyter?
Jupyter, sir. Even I use Google Collaboratory. Sir.
Okay, who is comfortable with Jupyter? Nowadays, even Jupyter Notebook, they have introduced a web browser based. Is there anyone with I'll go with always Jupyter. So if there are anyone with Jupyter, no one, then I'll give a call out, a random call out.
Sir, but I think I know how to download it.
Okay, but that is not sufficient, no, because when you teach to someone, you should be very comfortable. Arun Karthik, better you try.
Okay, sir.
I will give you both the codes that you can keep it in your machine after installing, after teaching how to install and other things configuration. Then you can run these 2 codes that I'll put you in the chat. Yesterday, I think I shared the first code example. Now I'll give you the second example, candidate elimination code, so that you can check. lab2.csv and Jupyter file. You can check the chat box, candidate elimination. Got it? Have you got it, Pa?
Yes, sir.
Yes, sir.
Okay, Kana. Okay. I downloaded attendance. Thank you all. We'll meet tomorrow.
So the post